Thank you, Gary. And we want to thank GRC Consultant again for their support throughout all the years. We've known Gary for a long, long time, and he's just a terrific friend and colleague. We have a very innovative session here for you. Well, we've got our 3 innovative technologies that are just stepping into the marketplace. And the third speaker also needs no introduction, is Greg Schultz. And I've known Greg for many, many years. He's a wonderful guy. And Mr. Biofilm, I would say. He's Professor Emeritus in the Department of Gynecology and Obstetrics at University of Florida, also the Director of the Wound Care Research Center there for many years. And he's pioneered a lot of our interest in biofilm and how wounds heal in the face of infection.
Well, while they're pulling up my slides, it's a real pleasure to have the opportunity to present today. This has been a fantastic morning, and I want to thank the program committee and also GR Consulting for sponsoring this presentation. So, as Oscar indicated, I'm Greg Schultz. I'm an emeritus professor at the University of Florida, and I'm going to talk to you today about Kane Biotech, which is a new biotech company out of Canada, and specifically focus on the targets of the major products, which are biofilms. And I'm now the Chief Scientific Officer, and I'm going to talk to you in the next 10 minutes about DispersinB and Coactive Plus. Now, Dr. Landis did a great job setting up the biofilm background story, so I won't go into this in any great detail except to say that there's a very high percentage of wounds that have mature bacterial biofilms when they are in a non-healing state. In fact, we have 4 new papers that are coming out using our biofilm-based wound care technology that shows that if chronic wounds have detectable biofilms using that rapid point-of-care technology, they will not heal until the biofilm is reduced. One of the major components of bacterial biofilms is the polysaccharide chains that are uniquely made only by the biofilm phenotype of bacteria, not by the planktonic bacteria. Another component that's important that helps stabilize but also causes a tremendous amount of inflammation is the free extracellular bacterial DNA that makes up, in many cases, about 20% of the biofilm exopolymeric matrix in chronic wounds. So I'm going to give you an oversimplified version of why chronic wounds fail to heal. And basically, we've heard today that there are many, many situations that can impair healing, but clearly data both from multiple laboratory and clinical studies show that the bacterial bioburden is a major factor that contributes to preventing wounds from healing. And it's not only the single planktonic bacteria, but also the presence of the bacteria when they're in the biofilm phenotype. Now, we've heard a lot about interesting situations of neutrophils and macrophages, and inflammation does good things when it's the right time, right place, and right amount. Unfortunately, when we have a bacterial bioburden that becomes very elevated, especially when we have the bacterial biofilms, because our immune system, our antibodies, and many of our antibiotics and antiseptics don't work well against biofilm-based bacteria because of the tolerance that's provided by that form. And what we and others have shown over the years is that you can measure these levels of pro-inflammatory cytokines. When the wound is not in a healing state, these are highly elevated. This leads to increased amounts of neutrophils, macrophages, and mast cells in the chronic wound environment. They activate, release proteases, the matrix metalloproteases, elastase, as well as the TNF-alpha converting enzyme, and also reactive oxygen species. Now, proteases do good things when they're at the right time, right place, and right amount. But in many of these chronic wounds, they're over 200 times the concentration that we see in acute wound fluid. And what many studies have shown now is that these proteases and reactive oxygen molecules have off-target effects, and they begin to degrade growth factors receptors, functional extracellular matrix. This results in decreased cell proliferation and migration, which we see as an acute wound that's converted into a chronic non-healing state. Now, what I'm going to briefly describe for you is that the two products that Kane is developing, the Coactive Plus and the DispersinB, will both kill planktonic and especially biofilm-based bacteria very effectively. And in addition, the components within Coactive Plus will inhibit the metalloproteases as well as the serine proteases, and so that the TNF-alpha converting enzyme is reduced as well as especially the matrix metalloproteases. So this takes out both the top and key portions of this amplifying cascade that results in non-healing. Now, very quickly, DispersinB technology was first described by Dr. Jeff Kaplan in the early 2000s. This is an enzyme that selectively degrades the polysaccharides that compose much of the biofilm matrix, especially of staph and strep pathogens. And it has the ability to be stable and formulated, as I'll show you, into topical applications that can act to break down the biofilm major component matrix, the polysaccharides from those pathogens. I'll also show you, just to jump to a key take-home point, is that it synergistically enhances the killing effects of other typical antimicrobials, such as the cationic surfactants, antibiotics, etc. So, a key question is how many of our typical wound pathogens make a poly-N-acetylglucosamine, PNAG, and you can see that there's both gram-positive, gram-negative, as well as eukaryotic and yeast cells. So many of these are some of the worst virulent bacterial pathogens that we find in chronic wounds. Now, the key is, how does it break this down and how fast does it happen? And just in laboratory experiments, you can see that within a matter of minutes, when mature bacterial biofilms from multiple species is exposed to a formulation containing the DispersinB, yeah, we can measure the breakdown of the matrix that's bound onto the 96-well plate. But even more important is this little visualization. These are large aggregates of biofilms from staph and strep, and you can see that within a matter of minutes, it just completely breaks down the polysaccharide matrix that composes the majority of those biofilms. Okay, so now what does it do in terms of synergistically killing many of these very severe bacterial pathogens that are great biofilm producers? And again, hopefully it's available. I guess we can see it over here a little bit. When we look at the ability of DispersinB alone or with a antimicrobial containing dressing, we can see that, yeah, DispersinB will effectively break down and help kill those. But when we combine that with a typical antimicrobial agent, FDA-approved antimicrobial agent, there's a synergistic enhancement of the killing of the mature bacterial biofilms. Right? Well, it's great to kill, but if we kill all and disperse all the bacteria, what do we do to the wound cells? So we have to have a balance between the ability to break down and kill the biofilm and not kill every wound cell. And so the good news is that we look at day 21 compared to the treatment of DispersinB onto the companion infected wounds, you can see there's very dramatic and statistically significant enhancements of healing. Okay, that's an infected wound. What does it do to a non-infected wound? And again, as you can see in these photographs of the pig wounds, that actually the DispersinB treatment enhances healing of even non-infected wounds. So it has very, very low cytotoxicity, which allows it to be used effectively without damaging the wound cells. The other product I'll very briefly talk about is Coactive Plus. This is a formulation that contains agents that inhibit metalloproteases and elastase. It reestablishes the optimal pH at about 5.5, contains antimicrobials, and importantly also for clinical use, it contains a poloxamer polymer. Now, unless you're a material engineer, remember that poloxamers are different than most polymers. Most polymers, when you warm them, they get thin. When you cool them, they get thick, like honey. Poloxamers are a different kind of polymer, and they do exactly the opposite in their thermokinetics. When you warm them, they gel, and when you cool them, they get thin. Now, this is important because this makes application and removal of the coactive product extremely pain-free and very effective, especially in patients that have high sensitivities and things like burn wounds. So how effective is the Coactive Plus wound gel in terms of killing multiple types of planktonic bacteria from these typical pathogenic organisms? Again, at 10 or 30 minutes exposure, remember this can be left on the wound, that they have phenomenal clearance, 5 to 6 log clearance, which would be what you would hope would happen. In addition, when these are added, when the Coactive Plus is added to mature biofilms, not just planktonics in the previous example, we again see that the coactive wound gel is extremely effective at reducing the level of viable bacteria in mature biofilms from both staph and strep species. And finally, the protease inhibition is again incredibly important in reestablishing an optimal environment in the wound bed to begin healing. So if we look at a common elevated protease, the matrix metalloproteinase 9, this is a gelatinase, not a collagenase. And you can see that in this typical laboratory example where the breakdown of collagen is revealed by a clearing of the stain zone, that the Coactive Plus with MMP9 essentially totally inactivates the enzyme activity. Now, it's not only able to inhibit the matrix metalloproteases, it also inhibits both the elastase and the TNF-alpha converting enzyme, a member of the superfamily metalloproteases. So in summary, what I hope I've done is expose you to 2 new products. The Coactive Plus wound gel rapidly inactivates these detrimental products of chronic inflammation, the matrix metalloproteases, elastase, and TNF-alpha converting enzyme. It will rapidly kill both the planktonic and biofilm types of multiple pathogenic bacteria and viruses and fungi. DispersinB cleaves this major polysaccharide, the PNAG, that makes up the major component of a variety, a large number of pathogenic bacteria and fungi. And this is kind of the thing that really intrigues me, is that there is a synergistic enhancement between breaking down the exopolymeric substance of biofilms by breaking down the polysaccharides and treating it with FDA-approved antimicrobials in a combined formulation. So I think this is the first time we've seen a enzymatic approach to selectively break down only bacterial polysaccharide components of the biofilm. And I think we're going to eventually be able to see that using these products in combination or separately will in fact make a big impact on biofilm control.